Hello, everyone, and welcome. My name is Rula Deeb. I'm a senior principal at Geosyntac Consultants in Oakland, California, and the coordinator of the webinar series on behalf of SERDP and ESTCP. Today's webinar is a tribute to Mr. Fred Lafferman, who was a coatings chemist with the U.S. Army Research Lab. Mr. Lafferman dedicated his career to researching, developing, and transitioning coatings for use on Department of Defense assets. He contributed significantly to the weapons systems and platforms SERDP and ESTCP program area. Mr. Lafferman's co-principal investigators will provide an overview of his achievements and contributions to this area of research on today's webinar. We will have 3 short presentations. First, Mr. John Escarcega will focus his presentation on chemical agent-resistant coatings. Second, Mr. Jack Kelly will discuss pretreatments and conversion coatings. And finally, Mr. Dan Pope will talk about advancing corrosion performance. We will conclude the webinar with a Q&A session featuring our 3 speakers. The next several slides provide instructions on optimizing your webinar experience. If you have not done so already, please download Zoom at the link shown here and provide it to you in your webinar registration confirmation email. If you're unable to download Zoom, you may view the slides using a compatible internet browser such as Firefox, IE, or Edge, and by creating a free Zoom account. If you continue to have difficulties in viewing the slides, or if your screen freezes, try keying Control and F5 to perform a hard refresh. If you are accessing the audio through your computer, click the arrow next to the Join Audio button, select Test Speaker and Microphone, and follow the prompts as they appear on your screen. If you continue to have difficulties, just call into the conference line shown here. You may also submit a comment using the chat box. Please use the chat box only for comments related to technical difficulties. The Q&A option should be reserved for questions for our speakers. In case of continued difficulties, you can now download a PDF of the slides from the webinar webpage. It has been uploaded and is available for download. And then call into the conference line provided to you in your registration confirmation email. Note that we will also be live streaming the webinar on the SERDP and ESTCP YouTube channel at the link shown here. Today's broadcast will be listen only. You may submit questions by using the Q&A box on the screen. You do not need to wait until the Q&A period to submit the questions. In fact, please submit them well in advance of our final Q&A session. And when you do submit them, we would appreciate it if you can add your organization name at the end of your question so that we can identify it during the Q&A session. With that, it's my great honor to introduce Dr. Robin Nisan, who is the Program Manager for the Weapons, Systems, and Platforms Program area of SERDP and ESTCP. Robin has been serving in this role since 2013. Prior to that, Robin worked at the Naval Air Warfare Center Weapons Division in China Lake, California, where he started off as a research chemist working on materials analysis, ranging from polymers to energetics, also solid state and organic to organometallic and ceramic materials. And he ended up as the director of the research department there. Robin received his doctoral degree in organic and inorganic chemistry from the Pennsylvania State University. Robin, please proceed.
Well, thank you, Rula. I appreciate that. I'm pleased to welcome everyone to today's SERDP and ESTCP webinar. SERDP is the Strategic Environmental Research and Development Program, and it was established in 1991 by Congress as a partnership between the DoD, Department of Energy, and EPA. SERDP's mission is to identify and address high-priority environmental science and technology opportunities that focus on DoD requirements. SERDP funds both fundamental research as well as advanced technology development that ultimately impacts real-world environmental management. ESTCP is the Environmental Security Technology Certification Program. Here we demonstrate innovative environmental and energy technologies. These investments capitalize on past investments under SERDP or other research programs and are designed to transition technologies out of the lab and into the field. Especially important in all ESTCP demonstrations is the ultimate transition to implementation and regulatory acceptance. SERDP and ESTCP are complementary programs with much of SERDP research occurring at the lab and pilot scale with occasional field efforts, while ESTCP demonstrations are primarily at the pilot and field scale, although occasionally supporting lab efforts are conducted. There are 4 program areas in SERDP and 5 in ESTCP. The Installation, Energy, and Water program area is only in ESTCP, while the other 4, environmental restoration, munitions response, resource conservation and resiliency, and weapon systems and platforms, are SERDP and ESTCP programs managed jointly by a designated program manager. Today's webinar presents results from the research and demonstration efforts that were conducted under SERDP and ESTCP in the Weapon Systems and Platforms program area. Mr. Fred Lafferman contributed to much of the work that his collaborators will discuss today. Weapon Systems and Platforms has 5 major focus areas: surface engineering, structural materials, energetic materials and munitions, noise and emissions, waste reduction and treatment and DoD operations, and lead-free electronics. Our webinar series highlights research and demonstration efforts from each of the 5 program areas. As you can see on this slide, upcoming webinars will cover a broad range of topics, including advances in the understanding of PFAS ecological risks, fate, transport, and treatment of munitions constituents in soil and groundwater, advancing microgrid solutions, and others. You can find additional information about upcoming webinars at this link. I would like to remind you that a copy of today's session can be downloaded from our webinar page. We would appreciate it if you would take a moment to complete the survey that will pop up on your screen at the end of the webcast. For today's webinar, I want to share some of my personal experiences and thoughts regarding Fred and his program management. You're going to hear a lot more about the technical efforts that resulted from Fred and his team's efforts in this webinar. I want to discuss some of his project management skills. A successful project rarely moves down a linear path. Roadblocks and decision points are common to most R&D or even demonstration validation efforts. Fred was a great PI. He understood when it was time to cut bait or when it was time to make a dramatic shift in order to achieve the project goals. What he did best was to convene the group of performers and stakeholders to reach a consensus on the best path forward. One other area I want to credit to Fred is his communication skills. Fred always gave excellent presentations to our technical committee and to other technical forums. But perhaps as important from a program management perspective, Fred always kept us informed of the progress of his projects and involved us in the decision making. One last point I want to make is that Fred was able to pass on his mentorship skills to a number of colleagues and successors, and you're going to hear from a few of them today. And I know a lot of you on the line today as well have benefited from Fred's experience and the way he was able to pass it on to all of us. With that, I hope you will enjoy today's webinar.
Thank you so much, Robin. It is now my pleasure to introduce today's 3 speakers. Mr. John Escarcega is a research chemist providing contract support for the U.S. Army Research Lab. His work focuses on current and future generations of coatings and formulating coatings with near zero volatile emissions and enhanced multifunctional capabilities, including the elimination of heavy metals for pretreatments and primers. John was the former lead for the camouflage coatings and corrosion team and DoD's chemical agent resistant coating commodity manager for over 20 years at the U.S. Army Research Lab at Aberdeen Proving Grounds. He earned a bachelor's degree in chemistry from Mary Washington University in Virginia. Mr. Jack Kelly currently leads the camouflage coatings and corrosions team for the U.S. Army Research Lab at Aberdeen, and also serves as a senior program manager for the coatings and corrosion team. Jack's work focuses on identifying technology gaps and transitioning state-of-the-art sustainable alternatives to address Army and DoD corrosion prevention and environmental needs. Jack earned a bachelor's degree in mechanical engineering from Northeastern University in Massachusetts. And finally, Mr. Dan Pope is a materials engineer and leader of the camouflage coatings and corrosion team at the U.S. Army Research Lab at Aberdeen Proving Grounds. Dan's work focuses on taking data gathered from field during inspections and incorporating data captured in laboratory settings to develop a predictive model for coating degradation and subsequent substrate corrosion on Army ground and rotary wing assets. Dan earned a bachelor's degree from the University of Baltimore in Maryland. And with that, we're going to transition to our first speaker. John, please proceed.
Well, thank you. Good afternoon. It is my joy and privilege to be part of this webinar and recognize our colleague, mentor, and dear friend, Mr. Fred Lafferman. Today, I would like to take the opportunity to share Fred's contribution to foundational efforts in the history of CARC and explore the details and data as we look to the future. As a researcher and scientist, I've grown to appreciate and recognize that so often our accomplishments are a result of being able to stand on the shoulders of past researchers and allow us to see further and forward to the future. Fred was one of those pioneers and giants, which brought us to this current position of insight and promise for the future. Today, we will remember the path Fred had walked and passionately shared with so many, and we'll look to the future, which is bright and promising as ever regarding technology advancement and potential progress we can make collectively. What a better way to say this. In the beginning, what a career. Fred begins in 1967. Alkyd enameled and olive drab with moderate luster was the primary color and the go-to coating. In the early 70s, Fred's primary focus was fully engaged to initiate and implement a new coating type, polyurethane, to replace alkyd technology. It was considered by many very risky. Why change, people asked, with a goal to create coatings with attributes that to this day are still being enhanced and improved upon. Agent resistance, visual and near IR, ultra low gloss, and extended durability, to name a few. So what was the result? Essentially, the first specification for chemical agent resistance, MIL C 4618. Fred's first specification he co-authored and also authored defining papers on key attributes for the first two-component solvent-based CARC system. Ironically, as we read the past reports and documents, it was not without controversy. Environmental concerns, user safety, cost, repainting inventory, maintaining manuals were the main concerns. Through Fred's persistent and patient, guided the community to the successful implementation. So I want to shift here and focus on a few key points. Given this background, I wanted you to take a look at the current requirements and what has evolved with our partnership with so many DoD elements, raw material suppliers, academia, and our numerous suppliers and vendors that have enabled this original work that Fred was instrumental in launching. The requirements: not only must the top coat be formulated to meet durability and performance as listed here, the top coats must also be able to be applied with relative ease and have basic attributes such as shelf life, stability, and all other properties to meet DoD requirements. It is a tall order, and continued efforts and support are required to stay in front of the technology. SERDP and ESTCP has been instrumental in such support. As we have been challenged to evolve and explore new technologies, it has been truly with the support that ESTCP and SERDP has provided to us. As we look at these, there's numerous elements. The water dispersible was fully funded. It was developed and implemented through SERDP, then ESTCP, as well as the first CARC powder coat, as well, were developed and implemented. I have often reflected that these were born from our first generation CARC that Fred ushered in. So let's take a comparative look at this 46168 to the current CARC. So as we look, the advances are significant, going from a highly filled near critical pigment volume concentration to our current system. It is a pleasure to see them in terms of lower solvent content, new polymer system, polymeric flatteners. All of these provided extended wear, and all of these attributes are significant. I'd like to take some time and go through in the next few slides and highlight those details. So as we look at this particular slide, it's one, extremely complementary to the support that we experienced through SERDP and ESTCP, but more dramatic was that as we were advancing these technologies, we were able to use the baseline that Fred had ushered in. And so while it was a dramatic improvement, you can see, and specifically the tallest bars are 46168 that was weathering rather terribly as it was moving further and further into weathering, and the water dispersible, which is the lowest bar. So at this point, with that basis that Fred had established, we were able to move forward with this. And the end game here was, with these dramatic changes, we were able to eliminate and cancel with replacement the 46168. And I just want to pause for a moment, and if you look at the actual weeks of weathering, the equivalent megajoules, and so the 97 weeks was approximately 2 years, and that was the actual megajoule. Just keep that in mind for the next slides or so. The next, I'd like to highlight the pigments and extenders. As I'd mentioned, we introduced polymeric flattening materials. And this SEM beautifully shows how the beads integrate within the film. Being a similar composition for the system, it greatly improved MAR resistance, UV, reduced chalking effects. The result is that our top coats are predominantly flattened using polymeric beads, and this goes through virtually all of our systems that are in play today. I'd like to direct your attention to the far right. And this, again, with megajoules, we're looking at 1,400 megajoules, which is equivalent to 5 years. And what this highlights, the bottom two are water dispersible materials, the polymeric, and then the second one is the silica. And then our 53039 moisture cure, again with polymeric, and then the top green graph is the silica. So it demonstrates without any hesitation the excellent improvements that polymeric flatteners provided. And again, this was all done through the initial SERDP effort. And this was a gap that when Fred was working and developing these materials, the go-to was using silicas and highly flattening. And even to this day now, we're looking for alternative flattening agents that we could use less of and have a more resin-rich system. So as we can appreciate, we have highlighted changes we can make in resin selection, or the flattening agent, or any of the raw materials listed. And often our approach is to target a particular goal or objective and then change or alter the raw material that would best assist with our goal or objective. It has proven to be an effective way to make change and advance the state of the art. The next few slides will highlight our efforts with pigment selection and our intent to improve our existing coatings. The key point here is that the selection of pigment types can influence how effectively we can influence the UV and the near IR, and in particular to create low solar absorbing coatings. The impact reduces the absorption of photons that are harmful to damaging the resin system, and also results in low surface temperature. And so the combination is a longer life for the coating itself. In fact, using LSA pigments after a 10-year equivalent of accelerated weathering, we had less than 1.5 color unit change. Exceptional performance, proving the premise that LSA pigments could do what we needed to do for our systems. This was even achieved with our black CARC, which would be the most highly solar loading, and the pigmentation visually was very similar using the LSA. Given the data gathered, we will move forward to shift our entire palette to use LSA type pigmentation to assist in our durability and extending the life cycle of our coating systems. And we hope this will assist further efforts in alternative resin systems, including non-isocyanate-based systems. So
thank you so much. Go ahead. Sorry about that.
Sure. It's okay. So in concluding my segment, as we look forward in transition technology, it has been a windfall to have a strong basis to work from. Without embellishment, Fred Lafferman provided that strong foundation, leadership, and mentoring for over 50 years, from our pretreatments to our Topcoats. It has been my honor to have been a collaborator and to have known Fred, not only as a mentor, but as a dear friend. So I thank you and look forward to questions at the end of this session. Thank you.
Thank you so much, John, for your excellent presentation and for your kind and well-deserved comments for Fred. At this point, we're going to transition to our next speaker, John Kelly. John, please proceed.
Well, good afternoon, everyone. As John said, and I as well am very honored and am happy to take part in this Fred Lafferman tribute. Now, although unlike John, I have not did not know Fred as well as John or Dan Pope for that matter, because well, certainly John has known Fred for a number of years, and Dan worked with Fred on a daily basis. However, in 2012, we got to work on a pretreatment project together. We built the project to work to investigate alternatives to the 15328 chromated wash primer. And so we had that in common. And that's when I learned how many people that Fred knew over the years and throughout DOD and throughout the coating community. He was a well-traveled individual for sure. And as Robin indicated, he's very keen on project management. So my intent here is to go over a couple of the projects Fred was intimately involved with, the pretreatment projects. And it's kind of fitting in that John gave sort of a past introduction to Fred's accomplishments, and then I'll give it's somewhat of a present day and how things are being implemented from now on. Okay, so a brief outline. First, since we're talking about pretreatments and conversion coatings, I'd like to give a little background and why pretreatments and conversion coatings are important to the Army. The following two bullets are the two projects I'll be discussing. First, as I mentioned, the DoD P15328 wash primer alternative, and then the zirconium-based pretreatments and conversion coatings for aviation and ground support equipment. And there were a number of awards that came along with the successful execution of these programs, and I'd like to mention those and follow that up with some final thoughts. So some background on conversion coatings in general. Fred was a paint guy, and I use air quotes when I say paint guy, right? And John gave you some background. He's an organic coatings person. So why did Fred get involved with chemical pretreatments? Well, he understood the importance of surface preparation. Any good paint guy, and I use quotations, knows the importance of surface preparation. And AR 750, as we all know, requires all Army-based ground equipment to have a full chemical agent resistant coating system. Now, the key word is system. That system, according to 53072, consists of a conversion coating or pretreatment that's in direct contact with the substrate. So in other words, if we go direct to metal with the primer, we're not in accordance with 53072. So why pretreatment's important? Because it adds that extra layer of protection. And the data generated by Elsley that you see on the right-hand side demonstrates that not all of the new equipment is properly coated. In some cases, some of the new equipment, it has below spec dry film thicknesses of the primer and top coat. So if you don't have an added layer of protection with the pretreatment, we could have premature failures. So the first project with regard to 15328 wash primer alternatives, the wash primer itself has been a workhorse for the Army and for the DoD for, gosh, since World War II, I believe. And however, it contains hexavalent chrome, and which we all know is a no-no, and it is high in VOCs. So facilities, Army facilities and DoD facilities that utilize the 15328 had to get exemptions to go direct to metal or had to pay local fines for like state and regulations because they go over the state limits for VOCs and had to pay fines. So in short, it was time to move on from the wash primer. So, but canceling the 15328 would leave a technology gap. There wasn't anything at the time that was approved to swoop in and be a drop-in replacement for 15328. So we couldn't just outright cancel it. So this began the project to find an alternative. The goal here was to find a replacement that could be applied in a very similar fashion to the wash primer. In other words, it had to be a spray applied, a dry in place type of an alternative. If not, then the users would be altering their process significantly, and which would increase or reduce throughput and increase work time. We conducted full-scale, of course, we validated these alternatives in the lab, and then, of course, conducted full-scale demonstrations to optimize the process. In some of these full-scale demonstrations early on, Letterkenny, very cooperative, Fort Benning, Anniston Army Depot, and all these to verify the performance and optimize the process. So just to give you an idea of the evolution of the project and the solution, way back in 2005, we started a SERDP project investigating non-chromate, no VOC coating systems, which kind of evolved into the 2009 project, ESTCP project for non-chromate zero VOC coatings for steel substrates. Now, taking a lot of what we learned there, we started this project funded by TMR, Toxic Metal Reduction, looking at chrome-free, low VOC spray-in-place pretreatments for mixed metal applications to replace the wash primer. At this point, we made revisions to the specifications, specifically TTC 490. We're transitioning the technologies as we speak, and implementation at several of the Army depots. So, and there's a lot here on the slide, but I'll just call your attention to the bottom bullet. Really, is that it enabled the success of this program enabled us to cancel the 15328 wash primer back in 2018, which saved us 24,000 pounds a year of hexavalent chrome, eliminating the wash primer, and certainly a lot of VOCs. Just a brief rundown of some of the results. The bar chart that you see is the B117 salt clog data. And if the circled bars are the wash primer itself, and I mean, just at first glance, you can see that it wasn't even one of the better performers of all of the alternatives that we tested. And what you see in the bottom, some of the test samples that are out on the beach at Cape Canaveral, or were out on the beach at Cape Canaveral, the bond rate 7400, which was a Henkel product, which is our leading candidate. It's a spray in place, dry in place type product, and it is certainly comparable to the wash primer in real world use. So just to run down the accomplishments, I think I mentioned some of the transition facilities. Letterkenny, Sierra Army Depot hasn't transitioned, but have expressed interest. And certainly the end product applies to many ground assets as well as aviation. So here, just a rundown again of some more accomplishments. The results allowed the cancellation of 15328, but also the main I think impact was made by the revision of TTC 490, Federal Specification TTC 490, which created really a paradigm shift in how pretreatments are approved and used today. Hex chrome is no longer mandated. It has created a pathway for new technologies and encourages innovations. The users now have, because there's a QPD associated with TTC 490, that is, there are several non-chrome options that they can choose from the QPD, depending on what their applications are. And if you want to learn more about that, there's a list of reports down below. So the next project is the zirconium-based pretreatments, conversion coating for aviation and ground support equipment. So here, the goal here is to identify a, not just a hex chrome-free conversion coating, but a chrome-free conversion coating for immersion lines. And what this does is, if you can treat steel and aluminum along the same line, you can consolidate the process on one line, run aluminum and steel through the line, and save a lot of space at the facility, which makes room for other processes such as e-coat or any other process that's important to that facility. Like any other project, we verify the performance and beyond, really, because we don't only test products in accordance to specifications, but we also go beyond that and make sure that these technologies are what we need are in the best interest of the Army. We document the environmental benefits versus existing hex chrome technologies. And so some of the evolution of this project, well, way back in, I think, 2008 is when Fred came back to ARL, and one of the first things he began was to look at non-chrome pretreatments. This kind of evolved into the 2009 zirconium oxide pretreatment, and then this successful program, which was co-funded by ESTCP, OSD, and Toxic Metal Reduction, the environmentally friendly zirconium oxide pretreatment. This technology really benefits all of the Department of Defense, not just the Army. It enables combining the process lines, as I mentioned, and it saves, makes a significant environmental impact and saves on cost because the alternatives themselves are ambient temperature or room temperature versus the old technology, which had to be heated to elevated temperatures. Here's a quick schematic on what the old technology used to look like for processing steel and aluminum versus the hybrid system seen below, where you can run steel and aluminum through the same line, saving time and space. All right, just quick results here. Aluminum zirconium-based is comparable to hex chrome and outperforms trichrome, and on steel it meets the requirements of TTC 490. And so on steel, here are some test panels that are on some training vehicles down at Camp Lejeune. Performance on steel is versus conventional zinc phosphate is comparable. And down below, you see the three samples. One's abrasive blasted versus X-Bond 4000, which is a zirconium pretreatment, and versus the zinc phosphate, all very comparable conditions after 2 years of exposure. Transition is ongoing. These are projects that were finished up maybe a couple of years ago, whether it's the wash primer or this. We continue to support the users in their implementation, transition to these new technologies, showing them how to use it. And on the QPD at TTC 490, we have instructions, manufacturer's instructions on what these alternatives can and can't be used on. So we continue to support those users. There's approximately 5 products qualified to TTC 490 here. 6 successful demonstrations were conducted, and it qualifies to replace zinc phosphate. And so I wanted to show the awards and recognition. We won the 2016 Secretary of the Army Environmental Excellence Award and the 17th Secretary of Defense Environmental Excellence Award. And there's a photo of the team looking their best, and they're all dressed up. Fred unfortunately couldn't make it that day, so we had to take a photo separately. And here's the team, the full team, as we look pretty much on a daily basis. And of course, Robin showed this photo earlier. And this is the ESTCP 2017 ESTCP Project of the Year Award. And Fred led this project for the zirconium oxide pretreatments. So final thoughts on Fred. As John mentioned, Fred's contributions spanned over 50 years or so. What's impressive to me is the major impact he made in the area of pretreatments and conversion coatings in just the last 10, 12 years. So his experience, his knowledge, leadership, especially his relationship he had with the entire DoD community and the coatings community in general, will be sorely missed and is irreplaceable. Thank you.
Thank you so much, Jack. As a reminder to our audience, please submit your questions by using the Q&A box on your screen, and we will get to them after our next presenter finishes his talk. Dan, the floor is yours. Dan, please proceed. You're on mute.
Hi, my name is Daniel Pope from the Army Research Laboratory. I've had the pleasure over the last 13 years of working very closely with Fred and being able to call him my friend over that period. During that time, there was so many projects he was involved with, and I'm very excited to be able to share a few of those with you guys today. So I'm going to talk a little bit first about some of the mixed metal primer work that he did. I'm going to move into some work that he did with helping to transition E-coat, move on to his efforts with aviation primers, and finally talk about a project that he had envisioned and started before he passed away in reference to modeling corrosion performance. So first, I'd like to talk about liquid primers. Fred, prior to coming back to the Army in, I believe, 2008, had worked with industry supporting DoD needs for coatings. With that, he got to go to a lot of facilities and see what was needed, and he also got to see a lot of failures in the field. As a person who works in the lab, I don't always get to see that, and most lab workers don't necessarily get to see how the end product works in the field like Fred had the opportunity to. So when he came back to the government, he had an understanding where our specifications were not allowing for higher performing products to be introduced to the field. Thus, we were kind of, in a way, causing a corrosion problem by allowing inferior primers onto our assets. One of the first things he did was looked at the 2 liquid primers that we use as part of the CARC system, 53022 and 53030. He went through, revised these specifications, worked with members inside of industry and also within the government to ensure that we canceled underperforming products, made them more environmentally friendly by eliminating volatile organic hazardous air pollutants, and at the same time reducing VOCs of these primers. And based off the requirements he put in the spec, he was able to drive performance of these liquid primers. His spec revisions opened it up from being a detailed specification to a performance-based specification. So this gave vendors more ability to use novel resins and novel corrosion inhibitors to make performance of these primers instead of using what we had called out in the specifications. This opened us up to brand new primers, and it also gave the opportunity for us to introduce primers that allowed for vehicles to perform, corrosion performance to be better in the field and ultimately give us a product that'll last longer in the field. A primer that fits into this is Electrocoat primers. The Army had specified Electrocoat primers, but there was a lot of holes in how it can be used. Unfortunately, the way specifications read, you don't necessarily understand the advantages sometimes of a primer that performs such as Electrocoat does. This project I'm going to talk about was funded by ESTCP to look at scalable systems for production using Electrocoat primers. And with this, we were able to kind of demonstrate the ability to coat complex parts in a way that we couldn't with traditional liquid primers. And you can see this with these panels that were exposed out in at NASA for a year. The panel on the left uses our traditional 53022 liquid epoxy primer. And you can see right along the edges, you have rust starting to bleed. Traditionally in specifications, as we're doing lab testing, we're not necessarily getting ratings from the edge. Usually with the specs, we are actually ignoring the edges and just looking towards the center of the panel. And you can see to the right of that is a product that used E-coat, and you don't have that same issue with edge. You have better edge retention, thus a product that looks better in the field. Also, these products are volatile air pollutant free, and they're extremely low VOC with minimal waste. So his work on this project was also to help understand how these processes work and how a system like this can be fit into an Army depot. And you can see from this diagram that really E-coat is meant to go directly from pretreatment, and the part would go directly into E-coat. So this project, actually the timing was great because some of the new pretreatments we were looking at, the zirconium-based pretreatments, allows for the users in a depot to go wet from a zirconium-based pretreatment directly into E-coat. Thus, with the foot space that we gained from going to a multi-metal zirconium-based pretreatment, we are able to add in a new process such as E-coat to a depot without the same capital investment that would be required if we didn't have the footprint. So I just wanted to show this to help tie together the pretreatment work Fred did along with the primer work. It really shows that he was looking at coating system as a whole and trying to find the best solution as a whole. So next, I want to move on to his work with chrome-free aviation primers. This was a project that was funded through by ESTCP with NAVAIR as the lead. I think this really shows the importance of collaboration in Fred's work. He always wanted to work with everyone who was going to be doing a similar process as him and he wanted to make sure that everyone involved had their say and come up with the best product overall for the DoD. So with this particular project, it allowed the Army to expand the understanding of current Class N primers. We were able to do some testing to kind of mimic what the depot does for repair and repaint, and from there, introduce some novel primer systems to get a feel for how they would work. This work right now is actually supporting what's happening within the Army as we're looking to fully transition to Class M primers on all aviation assets. At the same time, Fred was never stuck in today. He wanted to look forward, and he always wanted to make sure that the Army was looking forward to the future of coatings. And that leads us to a New Start program that we're working with NavAir on and demonstrating and validating aluminum-rich primers on DoD assets. This work will be advancing our non-chrome primers and hopefully the performance of non-chrome primers as we do these demonstrations and lead to a transition point. And Fred understood the importance of these demonstration programs. We needed this evidence that products perform on assets in the field before we could get PMs to sign off on changing, or even depots sign off on using the product. So with this particular project that's funded by ESTCP, we're going to be doing multiple demonstrations on multiple assets through multiple services, including the Navy, the Air Force, and the Army. So at the end, we'll have a lot of data that we'll be able to present moving forward and possibly have some primers to be the next generation of aviation non-chrome primers. So finally, I wanted to talk about the last project that Fred had worked on getting funded. And this is a SERDP project for a predictive corrosion model. One of the issues that we always have in the lab is that we don't have the same feedback of how things perform in the field. And we don't necessarily know whether our lab testing matches what we see in the field. From there, it makes it really hard to predict how a coating is going to perform in the field after completing the lab testing. Our approach is to use a Bayesian model to give us a predictive result. So we're bringing in historical CARC data. We had decades of data from doing testing on current CARC systems and soon-to-be fielded CARC systems. We also have thousands of surveys that was completed by the tank and automotive commands within the Army, looking at how their vehicles are doing in the field, corrosion issues that they see, and these included pictures along with descriptions of failures that they're seeing. With those two data sets, we're starting to marry them together, and we're starting to look for holes within that data that we can fill and create this robust model that would represent the real world. So the hardest part is that these two data sets are huge. We have thousands and thousands of pictures, tens of thousands of observations of parts and vehicles throughout the field. And we have all this lab data that is done in optimal situations. Because of the way field observations are done, we don't have necessarily the same metadata as we do in the lab. So it's hard to make those point-to-point connections. And we have to find a way to use these data sets with some supplemental data to connect the data to really be effective with our model. So we kind of look at it as a top-down, bottom approach, where our top data that we can get is our laboratory data. We know how well the panel is cleaned. We know how well the test is performing. We're able to control how we're reading or rating the panels and capturing readings. We know everything that goes into those results. For our observations, we kind of looked at that as our bottom up. We have these great observations from the field. This is definitely how the product performed. but we don't always have the data such as how well was the panel or how well was the substrate cleaned prior to being pre-treated, primed, top coated? What were the cure conditions? How thick or how thin was the primer or top coat? What kind of exposure did it see? Was this vehicle going from site to site, or has it just been at the same site sitting around? So we started building that back up and try to come up with the root cause for both. And we feel like with those root causes, we can make these two data sets really match to give us that information we need in the background to create the prediction. So to date, we've been able to start analyzing all of the field data. We've been able to create relationships and get understanding from parts and also vehicle inspections to give us a feel for, we see this, we understand why this problem's coming, and we understand how long this part or vehicle will last in the field with this problem that's evolving. From there, we've been able to start that relationship with the lab data, and that's where the modeling comes in, where we're taking these pieces of information, putting weight to what piece of information will produce the results that we're seeing, and getting a feel for how the model would work and the end results from that model. This project still has a few more years, and we hope at the end of this project, we have something that's very usable for us at ARL to understand what we need to look at for coatings moving forward to get accurate lab data on how things will perform in the field. And then also for our engineering community in pre-production of vehicles or even our depots, so they can understand that areas that may see more abrasion, may see more exposure to soldiers, may need a different type of coating, or possibly that the coating we're using is just not suitable for those areas, and they can make better material selections up front that will hopefully allow the vehicles to last longer in the field and reduce waste overall. So with that, just kind of want to make a couple conclusions based off this work and Fred's work that I've been with him on. So ARL owning specifications really helps to facilitate coating transition to the field. That's been huge with the time I've been with him. Every time he's looked at new materials or wants to look at new materials, he's found a way to work them into specifications. This allows us to transition it to the field very easily and catch on throughout the DoD community. Greener coatings do not necessarily mean reduced performance. There's other ways that we can get performance, and sometimes it's not always easy. Hex chrome is known to just be able to move from spot to spot to help prevent the spread of corrosion. And maybe with our pretreatments, we need to look at them differently, like Jack had presented. Maybe it's something where we need to rely heavily on the primer and just have a pretreatment in place that allows the primer to do a better job in corrosion mitigation. And finally, advances in data collection and helps with advances. Sometimes maybe it's not a material solution, maybe it's a testing solution we need to help move us forward and move us out of some of our older technologies. If we keep testing new materials as if we test chrome, we are going to get similar results, and we're not going to see something that prepares test as well as a chrome-based material. We need to look at how we're testing products, the data we're getting, and how it marries to the field data to really understand what we need. And finally, I just wanted to share a couple lessons from Fred. Fred was a planner. He knew the importance of planning, and it wasn't just within the project, but what happens after the project ends? How do you move forward with these materials, or what project would build on to the project we're finishing up? He also was very big on planning vacations. He loved in the later years of his life to take vacations with his daughter and his 2 grandchildren. And there's pictures of him. I got one up here, just relaxing, having a beer, and enjoying his time with his family. That's something that he loved. Sharing knowledge. If Fred did nothing else, he was going to talk about everything he knew, and he wanted you to know what he knew as much as possible. He was an open book. He wanted to share everything he learned. And as funny as this is, I put a picture of a golf course down here. This was a golf tournament I played with him, and he was making fun of me because I was swinging as hard as I can, and this was a green that was carrying over water, and I hit my ball so far over the green, he was laughing away. And it's hard to see in the picture. He hit after me. He hit a ball just below the hole between the water and the pin and got a birdie. And I don't remember what I got, but I'm sure it wasn't pretty. So just if I would have listened to his knowledge beforehand, before hitting that shot, I would have done much better. He was definitely willing to share it. Communication, Fred loved to communicate and cooperate with and work with everyone in the DoD community. I think if you ever went on travel with Fred, you knew that he loved having huge parties for dinner. I mean, it wasn't uncommon that we had to find a facility that could house 20 people at one table because Fred had invited so many people to dinner. But those were great times for us to communicate, get a better understanding of what's going on in work. And most importantly, it helped us build relationships within the DoD and with other partners that we work with. That was, I think, one of the most important things I learned from Fred was the importance of relationships. And finally, that leads me to the elephant at the bottom of the screen. I had a daughter 16 months ago when Fred was so excited for me, and he had given my daughter this elephant that's at the bottom. When I was working through these slides, I had a hard time thinking, what do I want to say? What do I want to say about Fred? And what should I talk about? And my daughter come walking around carrying this elephant that we, of course, had to name Fred, just yelling, Fred, Fred. So it helped me to understand that Fred has and the importance of relationships that had to be described or had to be talked about with Fred. And I just wanted to share that elephant and make sure everyone knew how important relationships were for him. So with that, I will turn it over to Rula, and I think we're ready for questions. I appreciate everyone's time.
Thank you so much, Dan. This was a very definitely touching tribute from all 3 of you that not only speaks to Fred's character, but also to his contributions to this area of work, tremendous contributions. We received a lot of questions that we're gonna get through, but just as a reminder for the audience, you can download these slides. They have contact information for John, Jack, and Dan if you have additional questions that we do not get to during the webinar today. You can also visit the weapon systems and platforms for much of the technical details that were discussed today and documented in reports. So we received a lot of comments about Fred that we'll try to interject, but also a lot of questions. We're going to start with a question from DEFCON Ground Vehicle Systems Center. And this is a question for Jack. Is there an anticipated cancellation date for the 15328 pretreatment wash primer specification?
Yeah, thank you for the question. I'm sorry if I didn't make that clear. Yes, the 15328 wash primer was canceled back in 2018, and with replacement TTC 490. So essentially, the user, whatever they use 15328, the user could go back to TTC 490 and select from type 3 and type 4, which are interchangeable, organic and inorganic pretreatments. So yeah, it's been canceled.
Great. Thank you so much, Jack. And while I get ready with the next question, let me share one of the comments received from the U.S. Air Force about Fred. I had been working with Fred for over 35 years, and I enjoyed learning from him. And he helped me better understand materials engineering as part of the Air Force Corrosion Prevention and Control Office. This is a comment from David Alex. Thank you, David. This next question is for Dan and John, and it's from IHD. And maybe Dan, you can take a crack at answering it first and then turn it over to John for additional comments. What obstacles were faced in developing the Class N primers? Was it straightforward to match paint flow properties? And were unexpected nozzle adaptations required? Dan?
So thank you for the question. There was actually a lot of challenges. For the Class N, well, I'll start with this. Class N primers are controlled by the Navy, and they hold that specification. And it's one of the great examples of where all the armed forces have to work together to ensure that we are getting coating systems for our fielded systems, or fielded equipment that we need. Class N provides a lot of challenges. One, you don't have the same inhibitor package. The hex chrome in the Class C products made for a very forgiving primer. The Class N is much more sensitive and needs a more pristine surface. It's not nearly as forgiving. And in the field, there is some differences. Some of the cure times and dry times are different, so our recoat windows are a little bit different. That is an issue at times with production that has to be worked through. And even with that, sometimes just, I can say a lot of the issues that we see with Class N and a lot of the barriers we had to work through involved fitting it into the production schedule and making sure that production can still happen the same way it was doing with Class C, but with these Class M primers. Did you want to add some more to that, John?
Oh, sure, Dan, thank you. I think one of the principal challenges has been from a chemical standpoint, where these alternatives, the mechanism in which they are inhibiting degradation is very different from what we have been seen or being realized with a chromate system. So that when you start going down that path, for instance, when we were looking at neutral salt or evaluating neutral salt fog or cyclic corrosion, we sometimes were getting less than stellar results, yet outdoors they were doing fairly well in comparison to our chromate system. So I think that's been, and I think we're going to continuously see that. And that was a good thing. We really asked ourselves, well, what are those chambers doing for us? And I think what we've concluded is that they're really a screening device, and they're no substitute for outdoor exposure, hence the desire, perhaps the holy grail, to find a more adaptable type predictive method. And that was certainly what Dan was highlighting in the last few slides. And then the second aspect is that especially for the non-chrome systems, they seem to be, again, a lot of that work in Genesis was from the aviation community, so it was tailored more, I think, to aluminum substrates. So the other challenge is to have these non-chromes to address both multiple substrates, ferrous, non-ferrous substrates. And then I think that part of that question was nozzles and nozzle types, and there was no dramatic changes. Things seemed to be able to be accommodated, but as Dan noted, there were changes. Thank you.
Thank you, John. And before I get to the next question, another comment that came in from Erica Macha from the Southwest Research Institute. I had the pleasure of working with Fred for several years and so enjoyed learning from him. He was an extremely technically skilled person, but also a kind person and very focused on sharing knowledge and ensuring that improvements for coatings weren't just evident in the lab, but translated to real world improvements. It was always a pleasure working with him, and our community misses him already. Thank you for that comment, Erica. All right, our next question is for Jack. And this is a question from Maxterial Incorporated. Chromate conversion coatings are thought to have self-healing properties. Do zirconium-based conversion coatings have the same properties? Jack?
Yeah, thank you. Well, I think we know the answer to that question is no. The non-chromate or non-hexavalent chrome conversion coatings don't have the same type of, we call them self-healing properties, or because hex chrome tends to go into solution a lot more readily and migrate to areas where it's needed. Some do, some of the, like say the zirconium and the trivalent chrome. I mean, we can go down a rabbit hole and talk a little bit more about this kind of thing. But when we, for example, in 81706, there's a group of pretreatments or conversion coatings that are approved for bare use. And I don't believe, say, for example, zirconium is approved at this point for bare use for that reason. So for that kind of applications, hex chrome is right now kind of a difficult one to replace. We're also looking at hex chrome, non-chromate sealers and post-treatments for various other conversion coatings, such as black oxide and zinc phosphate and heavy zinc phosphate and manganese phosphate. And with the synergistic effect of the non-chromate sealers and post-treatments with these other conversion coatings, it's enough to passivate the surface to prevent corrosion, but it doesn't have that migrating effect that hex chrome does. I hope that helps.
Thank you so much, Jack. Here's a comment from James Dorch at BAE Systems. Fred lives on in the coatings we are using for all of our vehicles at BAE. Thank you, James, for your comment. This next question is for John. John, this is a question from PPG Aerospace. Do you think there will be more of a shift of use to waterborne and or powder chemical agent resistant coatings?
Thank you. My sense is that while it may not necessarily be water dispersible or powder, I do believe, though, that we are seeing shifts, and perhaps the first shift we'll start seeing is just the selection of pigmentation, as I had described, with a low solar absorbing type pigments. And as PPG and other companies are aware, there's a lot of interest in 9-isocyanate based coatings. And so there's where I do anticipate more of a shift. I think, though, that as best as we can see, is that, and especially with this current administration, there's just an embracing of getting more green type systems. So the possibility of powder that is essentially zero VOC, no solvents, will probably be constrained only by having equipment in our facilities. if I were to be asked what would be the best stack up, it would be with one of our exceptional pretreatments, followed by a powder primer and powder top coat. The very necessity of those powders require an exceptional pretreatment. So you're kind of getting a 2-fer or 3-fer, if you will, when you start moving in that direction. So I think that in summary, there will be a continuous push for more green technologies, and whether it's be water, powder, or even with our existing one-component systems or non-isocyanate, all of them will be demanded upon to be lower in VOCs and easier to apply. And as Dan had mentioned in an excellent comment, an application where it's not so picky and can be applied more easily. So thank you for the question.
Great, thank you. Another question, another comment about Fred from AMCOM Corrosion Office at Redstone Arsenal from Dusty Hope. I had the privilege of working with Fred on several projects. He was always available to answer any questions that I had. He was always a joy to work with and travel with. He loved his family very much and spoke of them often. Thank you, Dusty, for your comment. This is a question for Dan from Andhra University in India. Can you elaborate on the Electrocoat specification parameters you referred to in your presentation?
The electrical, let me see. Oh, so I believe there was an image on slide 66 that's being discussed. So there was an image that was put in there, and while at this point we haven't incorporated any EIS data into our model, we eventually are looking for a way that we can do that and be effective. So at this point we haven't moved towards that, but it's something that's we want to do. Unfortunately, at this point we just haven't done it. Unfortunately,
Thank you so much, Dan. And I'd encourage the person that asked the question to contact Dan directly for additional information on when these parameters will be developed, if any. This next question is for Jack. It's from Raytheon. How does the zirconium-based conversion coating stand alone perform under B117 testing in addition to the system level performance? Jack?
Yeah, I'm here. I'm trying to understand. I don't know. In addition to the system, oh, I see. So how does it perform by itself versus with an entire coating system? I'm thinking, right? I think the best way I can answer that question at this point is to say that it doesn't hold up bare at this point because we don't have it approved for bare use on, say, repairing of anodized coatings just yet. However, it does hold up very well in a system with a complete coating, a CARC coating system.
Thank you so much, Jack. One quick comment from Randy Terrell at NCP Coatings. It was great to hear from the people Fred worked with and remember all of the things he worked on over the years. He was a great chemist and a great guy and always a joy to work with. Thank you, Randy. This next question is for either John or Jack. Maybe we'll start with you, John. What is the process for getting a Topcoat approved and listed on a qualified product database?
Sure, thank you. So essentially, the Army Research Lab is the technical authority and approving authority for most of the coating systems on assets, and that includes ground vehicles and vertical lift assets as well as support equipment. And so if individuals have technologies that they would like to have qualified and they fall under a particular specification, the best point of contact or entry point would be to send an email to Jack Kelly and simply indicate the technology that you're interested, let's say a Topcoat. And if you are familiar or have awareness of the spec number, and say I'd like to submit or have a technology to submit to that Topcoat specification, and then that will be responded, and then that process will begin. The other scenario that exists, and again, is the Army Research Lab, if there's technologies that may be outside the specifications, though may give us a quantum leap or an advancement that we're struggling with, or there's a gap, that could also be addressed. Similarly, send Jack an email, and at that point we would take a look at it and discuss what possibilities we could pursue. So thank you.
Thank you, John. Jack, would you like to add anything?
No, that's accurate, what John was saying.
Excellent. Another quick comment about Fred from Paul Robinson at the United States Army Aviation and Missile Command, G4. I, like so many on the webinar, worked closely with Fred since the early 90s. I counted him as a great friend, mentor, colleague, and inspiration. We were so successful on many projects over the years because of his forward-thinking intellect and understanding of how to fix the problems we faced. Thank you so much, Paul. The next question is for Dan. It's from the University of Houston. Dan, are you looking at corrosion in cold environments with icy conditions?
So for our ground equipment and primers used for ground equipment, we don't do too much in the way of low temperature testing. For aviation equipment, the primers are tested for flexibility at low temperatures. But for exposures, most of the time we are looking at hot, humid sites for our exposures on outdoor testing.
Thank you so much, Dan. Another quick comment from Karen Chan at AMRAM. Fred will be truly missed. Thank you to all our presenters. And as we move towards wrapping up, two quick questions for all three of you. You discussed a lot of, and you presented a lot of information about new technologies. Starting with John, what would you say are the most difficult challenges to implement and transition some of the new technologies that you presented? John?
Well, I think ironically, once the technology is in hand, if you will, I think one of the biggest things is persuasion, and people may giggle when I say this, though as individuals, I think we're often very reluctant to change, and I think that one of the biggest challenges is that once we're seeing that we need to make movement, the ability to persuade individuals that this is the correct thing, this is the path, even though it may be difficult, even though it may be challenging. I think that's perhaps I think one of the challenges that I had seen throughout. And as we first introduced Fred about 46168, it was interesting to see the number of very sharp comments about eliminating alkyd systems because they seem to be working so good. Why would we go to this urethane? So that would be one of my first points as far as a challenge for implementation. And I'll turn it over to either Dan or Jack. Thank you.
Thank you, Jack.
I'm sorry, could you repeat that question?
What do you see as some of the challenges to implementing and transitioning some of the technologies and advancements we discussed today?
That's a good question. I think from my experiences, it has been the really the user community and the user buy-in. I think to gain the confidence, because the user community and we'll say the Army depots and such, they're used to doing things a certain way, and the way they've done it has really worked for a number of years. And I think in a lot of ways, folks like us who work in laboratories, who come down to the floor, the production floor, and say, hey, we think you should do it this way. I think at first, I think Dan spoke to this before too. He said, Fred earned the respect of the folks who are down on the floor. People know that you've done this before. They know that you know what they do and how they do it. So I don't think it's enough to just throw a bunch of test panels in a chamber and come up with some data and reach a conclusion and tell the user that, hey, based on this data, you need to start doing this. You have to prove yourself, prove to them what you're doing is the right way to do it, and you get their buy-in. And I think implementation really comes easy after that.
Thank you so much. Dan, would you like to add anything?
Really, John and Jack's answers were great. The biggest problem is just communicating with everybody what your product can do and why they should use it, and getting them to see the full picture instead of just one number. It's so easy just to get fixated on possibly a B117 result. Oh, I got 3,000 hours with this, 3,000 of this, and B117's got to be better than the 2,000 hour product. And that's not the whole picture. So it's really something Fred was good at, communicating the whole picture, getting people to buy into his vision of what it should be, and from there, moving it forward in documentation.
Thank you so much, Dan, and thank you, John and Jack, for putting so much effort into this, into planning this webinar, and Robin for your leadership. I'd like to read one more comment before we wrap up. This is from Jonathan Love at PPG. Fred was always a pleasure to work with, and it's great he was able to do what he obviously loved and was committed to ARL for such a long time. He set the bar for dedication to his work higher than most of the rest of us will ever be able to attain, I think. So thank you so much for that comment, Jonathan. And with that, I'd like to thank all of you for your participation, and remind you that our next webinar is on Thursday, April 8th, on advances in understanding PFAS ecological risks. The webinar will feature two speakers, Dr. Mary Kurz from the Academy of Natural Sciences of Drexel University, and Dr. Jamie Suski from EA Engineering, Science and Technology. Registration is open, so please visit the SERDP and ESTCP webinar webpage to register for this and other future webinars. Also, before we conclude, I would like to remind you that both the audio and a copy of the presentation of today's session will be archived on our webinar webpage in case you would like to refer to them in the future. We would appreciate it if you can please take a moment to complete the survey that will pop up on your screen at this time. Again, thank you for participating. This has been a very special experience to be part of this webinar. And we do encourage you to download the slide and review snippets of Fred's work. This concludes today's webcast. Thank you for your attention.